Heinemann Higher, Chapter 9 on Integration, the mixed questions, exercise 9 at the end. Number 13. Now there's a velocity distance graph here. So this graph shows the velocity of some particle at different times. And the first bit's just a description. What does it say? I've got to keep the book here. Between 0 and 2 seconds, the particle moves to the right. So maybe I'll put a wee diagram. So here it is. We'll make the origin there. That's where it's starting. It's starting there at t equals 0. So there, if you like, also the distance is 0. The particle moves to the right between 0 and 2. Describe how its speed changes. Well, it shows you there. It starts at 0, increases to a maximum, and then slows back down to rest at 2 seconds. So I just have to write all that down. Starts at rest, increases speed to a maximum, and then slows back down to rest after 2 seconds. B. Describe its direction and speed between t equals 2 and 3. Well, after it's accelerated up to a maximum and then decelerated back to rest, thereby moving along, so it started off slowly, speeded up, and then slowed down again to come to rest at some further point, here at t equals 2, then the speed reverses, I should really say velocity, the velocity reverses, so it's going to be going backwards. It starts to accelerate backwards to a maximum and then decelerates to come to rest at 3. So during the first phase it's speeded up and then slowed down to rest here, and then it's starting to go back, speeding up and then slowing down again. The velocity reverses and the particle moves back to the left, accelerating to a maximum velocity and then slowing down to come to rest at t equals 3 seconds. So it looks like this. It's going forward and then it's come back to finish somewhere, I don't know, somewhere about here maybe, t equals 3. C. Calculate the total distance travelled between 0 and 3. Now you have to watch out for total distance because it's going forward then backwards. If you just work out the overall value from 0 to 3, then that portion will cancel out that portion. Now the first thing would be this. The velocity is the rate of change of distance. I've got a velocity equation. If I want a distance, then that distance will have to be, I'll have to undifferentiate it. It'll be the integral of v dt. And the integral, of course, means, another interpretation rather of the integral is the area under the curve. So if you've got a velocity time graph, then the area under the curve represents the distance travelled. So here I've got a positive distance travelled, since this area is above, that was it going forward. Here there's a negative distance travelled, which means it's then going backwards. And I can't do it in one go, I'd have to do it in 2 separate parts. I'll have to find this part and this part separately. So when it comes to this, I'll have to find the 2 parts. So I'll call it distance 1. The first distance will be, work it out from 0 to 2 of t cubed minus 5t squared plus 6t dt. Separately, I'm going to work out this distance here. I'm going to work out S2, which will be the same integral. Well, this time it's from 2 to 3 of t cubed minus 5t squared plus 6t dt. I could work them out at the same time. I could work them out at the same time and add my 2 answers, but remembering that this part's going to be negative, I could actually calculate this, subtract this answer to get my answer in one go. But no, I'll keep these 2 parts separate because I can see there's a third part that wants bits and pieces of them. So if I left myself enough room here. So S1's going to be this thing. It's going to be up to 4 divide by 4, up to 3 divide by 3, up to 2 divide by 2, evaluated at 0 and 2. And S2 is going to be exactly the same thing. 5 upon 3 t cubed plus 3 t squared from 0 to 2. It's getting a bit messy. So this part's going to be working out at 2. So it's a quarter of 2 to the power 4 minus 5 upon 3 of 2 to the power 3 plus 3 times 2 squared minus, I'll just put 0 because all the terms involve a t. And for this one, I'm going to have a quarter of, what have I put down there? That's 2 to 3. A quarter of 3 to the power 4 minus 5 upon 3 of 3 cubed plus 3 times 3 squared minus, and the other one will just be this part here. Sorry, you'll have to go. Minus, here we go, a quarter of 2, but I don't need to work it out again though. 5 upon 3 of, here we go again, plus 3 of 2 squared for that part. And then it's obvious from this what's going to happen. If I was to add them together directly, you can see that this calculation's the same as that calculation, and this part would cancel out that part if I added them directly, only leave me with this part here. There, that's why these areas would partially cancel to leave a smaller answer. So I want to work out these parts separately just now. So S1's going to be, what have I got? 16, so that's 4. That's going to be 40 upon 3, and that's going to be 4's 12. This one's going to be, that's 81 upon 4, minus, I'll knock out one of them, so that leaves 45. Plus, and that's going to be 27. Put it in a bracket, minus the same thing as that. 4 minus 40 upon 3 plus 12. And now I've run out of room, so I'll have to go up here. So put this up to the top. What have I got for the first distance? The distance between 0 and 2. I've got 4 and 12 is 16. So I've got 16 minus, now 40 upon 3, that'll be 13 and a third. So that's going to only leave me with 2 and 2/3. S2 is going to be, working at this part, I've got, well, negative 18. So I've got negative 18 plus, and that's 20 and a quarter, plus 20 and a quarter for that part of it, minus, and this other part is obviously 2 and 2/3. It was the same thing. So that leaves me with 2 and a quarter. So I've got 2 and a quarter minus 2 and 2/3. Then, putting that together, this part's going to be, if I want to add the two parts properly, that's going to be 2 take away 2 is nothing, that's a quarter. I better make that all to 12ths, so that's 3, and that's going to be 3 into 4 minus 8, so that's going to be negative 5/12. That gives me the areas of the two parts. That means that this area, I'll put it in red, here, is 2 and 2/3, and this area is negative 5/12, or rather, the distance travelled in this part is 2 and 2/3, and the distance travelled in this part is negative 5/12. It went forward 2 and 2/3, whatever's, and back 5/12 to come to rest there. But part C said, calculate the total distance travelled between 0 and 3. So that means the total distance will be the absolute values then, ignoring directions, will be 2 and 2/3 plus the 5/12. And 2 and 2/3 plus 5/12 is a little bit of a pest because I've got fractions again, make them into 12s, so that's going to be 8 plus 5, which is 13, which is 1, which is going to get another 1 to the whole numbers. There's 3 and 1/12 units, unless there were actually units in it. It doesn't actually say, so 3 and 1/12 units was the total distance travelled forward and back. Part D says, how far is the particle from the origin at t equals 3? Well, that's easy. It went out 2 and 2/3 and it came back 5/12. So what's the difference between them? It's going to be that 2 and a quarter, but I'll set it out. It went out 2 and 2/3 and it came back 5/12. So if I subtract them, I'm going to have 2, and what does this come to then? 4 times it, 8 minus 5, that's 3/12, so that's a quarter, so no surprise, 2 and a quarter units. After 3 seconds, the particle will have come to rest 2 and a quarter units from the origin. Question 13.